In an earlier video, I talked about these things called texture stages and how you're essentially allowed to draw using multiple texture samplers at the same time in computer graphics. And at the beginning of that video, I made a comment about how that might seem a little bit ridiculous if you've never thought about it before. As it turns out, the same thing is more or less true on the opposite end of the equation. You are allowed to draw onto multiple surfaces at the same time in computer graphics, and likewise, that might sound a little bit ridiculous if you've never thought about such a thing before. Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and let's talk about multiple render targets. This is going to be a fun one. So, this is a 3D toon shader I wrote. This isn't something that you need to be using 3D for, this is something that you can do in any drawing, in any 2D game in GameMaker, or in anything else. But this is an advanced effect, and I do intend on using multiple render targets for something for this 3D toon shader soon. And I'm going to assume that if you're interested in such a thing, 3D graphics are not that scary to you anymore. In theory, this should be pretty easy. So this is my this is the GLSL version of this toon shader that I wrote. In the last video, I made an HLSL version of this toon shader. HLSL being the high-level shader language, which is a different shader language that you are allowed to use in GameMaker. That's not what's running right now in that demo that I just showed. What's currently running is the GLSL ES version. A quick rundown, this is at its core a lighting shader. I'm not going to spend too much time going through it, but there is a couple lines of shader code which boil down to a final color, which is evaluated, and that final color is passed into GL_frag color. I've made a ton of shader videos in the past. If you want to see the different things that led up to this point, I will have a link to that playlist in one of those little pop-out card things and in the video description. And I recommend going and catching up on those if you haven't already. GL frag color is, of course, the color of the pixel that the fragment shader is going to ultimately put on the screen. This color, this GL frag color here, is going to be written to a surface in GameMaker, and that surface in question, which it is going to be drawn onto, is going to be either whatever surface you set when you say something like surface set target, and you supply this function a surface, or if you didn't do this, it's just going to be the application surface. I have also recently made a video on the application surface. If you are not familiar with the application surface in GameMaker and you want to do advanced effects such as these, I strongly recommend becoming familiar with the application surface, because it is something that you will be seeing a lot of when you do advanced graphical effects. Again, the link to that video will be in one of the cards and in the video description. Anyway, back to multiple render targets. If you were to go and create yourself a surface, I'm just going to say surface equals, let's call this something else. Let's call this something actually helpful. I'm not famous for giving my variable names helpful names, unfortunately. Surface extra is going to be surface create. We may as well create this with the same dimensions as the application surface. Surface get width. The width of the application surface and the height of the application surface. If we wanted to, actually, let me disable the application surface first, and then manually draw it later. We can say application surface draw enable. We're going to set that to false. This will cause the application surface to not be automatically drawn. Again, if you watched the last video, this should be familiar. We do not see the game world. The game world is not being drawn because the application surface is now not being drawn. And then we can go into the draw GUI event or the post draw event or whichever one you prefer and say draw surface application surface at the coordinates 0, 0. This is going to cause the game world to come back, because we are actually going to be drawing said application surface. Okay, link is back. You could, of course, draw surface underscore extra instead. You can do 3D drawing onto any old surface. I did not explicitly say this at any point, I don't think, about drawing in 3D onto another surface, but you can. I don't think it's too great of a leap in logic to figure out how to do this, but if necessary, I'll make a video specifically about this at some point. Surface set target surface underscore extra. When we're done drawing at the end of the draw event, surface reset target. And this is going to draw everything onto the 3D, so onto the extra surface, and we can see the game world. And we are basically completely ignoring the application surface from this point on. So this is how you would render onto one surface at a time. So in a similar fashion to when you set the main surface target using the surface set target function, and this basically replaces the application surface in whatever you're drawing. There is another function called surface, and you may have seen this while poking around, set target extended. There is an extended version of this function, and this takes two arguments. This takes an index and an ID. I am going to stop drawing to the secondary surface, and I'm going to resume drawing to the application surface to hopefully make things simpler. I personally think having fewer surfaces floating around makes things simpler, but I don't know if switching between them, which ones I'm using like this, is more confusing than it has to be. You can see this function takes two arguments, an index and an ID. So, and honestly, this is kind of backwards from the way a lot of other GameMaker functions work. We'll start with the ID. The ID is just the ID of the surface. So in my case, that is surface underscore extra. And the index is the first argument, and this is just going to be the index of the draw target that we are drawing to. So unlike when you say shader get sampler index, the extra surfaces that you can draw to in a shader do not have a name. You don't name them. You don't give them a name like ramp text or anything like that. You just give them an index. The index of the main surface that you're drawing to, which is, again, normally the application surface or whatever you specify with surface set target, is 0. Because in computers, things tend to be indexed from 0 more often than not. 0 is going to be the index of the application surface in this case. And if we want to supply a second surface to draw to, we can say instead 1. Or 2, or 3. I believe commonly you're allowed up to 4? I forget off the top of my head exactly how many render targets you're usually allowed to have. I believe you're usually allowed to have at least 4 for PCs, and on PCs, and fewer than that on smaller devices. Anyway, this function here, surface set target extended, differs from the regular surface set target in that you don't have to reset it. Normally, if you use regular surface set target, and if you don't reset the surface target when you're done, you will have just your game crash. But that is not the case when you use surface set target extended. In fact, there is not a version of surface reset target for the extended version of the function. That can be nice. It's one less thing to worry about. Now, how to exactly use this? So in theory, if you're using GLSLES, this would be as simple as, instead of using GL underscore frag color as the value that you assign the final color to when you're drawing, simply frag data. And GL underscore frag data is an array. It contains the different draw targets that you use. And in a perfect world, this would be all you have to do. You can see I am using GL underscore frag data index 0 and assigning the final color to that. And in a perfect world, all I'd have to do to access surface underscore extra over here to draw onto it as well at the same time would be to say GL underscore frag data of index 1. And I could set that to final color. I could set that to something else. This could be just a vector 4 of like just red, pure red with no color information from the texture or lighting or anything. As it turns out, we do not live in a perfect world, and thanks to GameMaker being GameMaker, this will break the game if you try to access anything other than index 0 and GL underscore frag data. A lot of the times, when people say things that they wish GameMaker had, they talk about things like a 3D room editor or built-in functions to import an OBJ file or something, or things of that nature. I honestly don't care about any of that. I can write both of those. I can write code to import an OBJ. I've done 3D room editors. It would make me really happy though if this line of code right here would work without causing the compiler to complain at me. There are a couple other things that it would be nice to be able to do. To sample from a texture in the vertex shader instead of only in the fragment shader would be pretty nice. But this one line of code right here, working without causing the game to break, that's all I want in life. That would be like the best Christmas present ever or whatever. Get on that, Yo-Yo Games. Maybe by like 2025 that'll actually happen. Anyway, I have been told that if you were to use GLSL as your shader language instead of GLSLES, then this would work. I have not tested that theory. Later on, after I finish recording this video, I will do some experiments with my Raspberry Pi and let you know the results.
Hey.
That leaves us with HLSL. So I've been making videos in the past on writing shaders in HLSL, the high-level shader language, which is used by DirectX and Windows. And I said that I would be coming back to it for something exciting in the future, and that exciting thing in the future is going to be this right now. Again, because all of these things that I do in these videos tend to be cumulative and build on each other, I recommend going and watching those videos on the high-level shader language. Links to those things exist. You see how this works by now. So over here in HLSL land, the output of the shader is a struct, which I have named PS output, the pixel shader output. Right now it only contains one thing, which is a float4 named base, which is essentially the base texture. And this is the tune shader code, which is which evaluates the color, and it calculates the color based on the lighting and the texture lookup and some other things, and assigns that final color to output.base, and then returns the output object, the output struct. Let me just go and change the shader that is being used over here to the HLSL version of the tune shader so that we can draw onto that instead. I believe all of the things that burned me in the last video when I was trying to convert this shader to HLSL. I've got to update the shader and change the name of the variable of the uniform that I set from ramp text to ramp texture. If I run the game now, the shader is going to be working in HLSL. Okay, there's Link. He's got a tune shader on him, and he's slightly blue as the pseudo day-night cycle cycles through. So that color, everything on Link that is being drawn, is currently in output.base. And in the pixel shader output struct, you are allowed to have more than just one member. You are allowed to have something else. Let's define a float4. What did I call it over back here? I think I called it like surface underscore extra. Let's call it extra. This needs a semantic. The semantic for the base texture that we were rendering onto, the base surface that we were rendering onto, back when we were just using a single render target is sv underscore target 0. If you want to use multiple, you can change that instead to sv underscore target 0. Sorry, did I say target 0 the first time? It was just sv underscore target, obviously. And if you want to use a second render target, sv underscore target 1, you may observe that that these are indexed from 0, and target 0, target 1 are the same thing that you would use pass the argument to surface set target extended. If you were to add a third surface that you are rendering something onto, you would make the index 2, and you would use sv underscore target 2 as your output float4 in the pixel shader output struct. And then we can assign to this down here. Output.extra is going to be a float4. You can make this the same thing as the original color, as the base actual like color of Link with the texture and the lighting and everything. That's not really useful to us. I'm just going to start by let's just write a bright red color. Let's go with 1 point instead of 1, 0. Let's just write a bright red color to this to the secondary surface. So if I run the game now, you wouldn't be able to see anything because this isn't actually being put on the screen. If I were to, instead of drawing the application surface, drawing surface underscore extra or something on the screen, you would then see it. I am going to set this up real quick so that if you're holding down the space button, you will see surface underscore extra being drawn. Otherwise, you will just see the application surface being drawn. And this is going to let me shift between them. So let me run the game now. And you can see Link is still here in his normal colorized version. And if I were to hit the spacebar, some of you may have an idea of what this is. Some of you may recognize this. A lot of you have probably seen this before if you've done anything involving drawing onto surfaces. If you're not seeing it immediately, it'll probably help if I move the mouse. This is what I often refer to as the Windows 95 effect. And this is caused by essentially the surface not being erased between frames and the contents of the surface that were drawn on the previous frame staying there when you draw something fresh. And that's what causes the effect of something that you try to draw being smeared around on the screen. Sometimes that is an effect that you would want if you want to actually allow the user to literally draw on the screen as if using a pencil. but many times that is not what you want. So, as with any surface, if you want to be able to erase it between frames or at any other point, you can use the handy dandy draw clear function, and that will erase the contents of a surface. It will reinitialize the depth buffer, and it will fill the surface with a solid color. In this case, black. Black is fine for our purposes. I can say surface set target surface underscore extra. When I'm done, surface reset target. And in the middle, we can, when surface extra is set to the target, we can just draw clear. And that will erase the surface. And then we can go back to what we were doing. So now when I run the game, you will see link is still here. Obviously, I haven't actually done anything to the application surface. And when I hit the spacebar, we just have link in red. We don't have him being smeared all over the screen like we had before. Good old Windows 95 effect. Without actually having expert knowledge about how old version of Windows works, I would be fairly certain, I would be fairly willing to bet that that's actually what caused the issue on Windows 95 too, when you like click on something on the screen and drag it around and you see the little trail behind it. Most likely that was something going wrong inside the operating system and failing to clear the frame buffer every time the monitor refreshed. How many of you remember that? How many of you are old enough to remember that? It wasn't exclusive to Windows 95. It would happen in like Windows 98 and 2000, and even I think XP once in a while too. I was 5 years old in 2000, and like watching the computer glitch up like that was like my favorite part of using computers at that time. Anyway, back to multiple render targets. You can put whatever you want onto these secondary surfaces. Generally, when you're only drawing to one target, you're usually interested in like drawing things as they would appear on the screen. You would usually like draw the shape of an object with the appropriate color and lighting shading and everything like that. Oftentimes when you are using multiple render targets, you are not actually doing that. You are looking to write some additional source of information. You are looking to create a surface with additional information about a scene. This can be things like the world normals of an object. You may also want to write depth to a surface because GameMaker doesn't actually let you access the depth buffer in any meaningful way. I'll make an example of the world normal first. So this is a vector 3, the world normal, and it has each of the components have a range of -1 to +1. If we just simply turn that into a vector 4, input.world norm, build a floats4 containing the input.world norm for red, green, and blue, and 1 on the alpha channel. This will look somewhat interesting. This is not actually correct. This is not actually what you would consider correct information about drawing a world normal to a screen, but it's a place to start. So normals vectors have a range of -1 to +1, as you probably know by now. Colors do not. Colors have a range of 0 to 1. So instead, if you are willing to forgive the linguistic humor, normalize this. You would divide the world normal by 2 and then add 0.5 to that vector, and this will put the world normal. This will essentially shift the value of the world normal from a range of -1 to +1 to 0 to 1. This isn't super important, so I won't spend too much time explaining that mathematical equation. Although, if you intend to do things with shaders involving normals, such as normal mapping, and some other things, you probably would like to bear that in mind. How you would like to convert normal information to and from a color. Anyway, when I hit the space bar, this is a color scheme you are probably familiar with if you've ever seen things like a normal map in either poking around a game's files or in 3D modeling software or something. I will make other videos on the subject at a later date. Anyway, that's normal mapping. If you want to write something to the depth buffer, GameMaker, as I said, does not give you access to the depth buffer. Before I continue, I will say that I know some people who would get fairly upset at you for doing this because in most modern graphics APIs, the depth buffer is something you would just be able to use without having to go through a shader to do it. And some people consider this like an incorrect way to use the graphics API. This is just another one of those things that it would be really, really nice if GameMaker just allowed us to do. Anyway, that's a rant for another day. Depth information. So depth is the distance of from the camera to a fragment, or I guess a pixel in HLSL land. We can create, much like things like position, color, texture, world, position, world normal, whatever, we can work this out by calculating the depth in the vertex shader for each vertex, and then passing it to the pixel shader as a varying, or as the vertex shader output anyway. So float, I'm just going to call that depth. The semantic can be depth because I said so. And we can copy this over to the pixel shader, ps input depth, and we can define this in the vertex shader. Output.depth is going to equal, and this is going to be going back to I-space coordinates, as we have done many times in these videos, getting something's position relative to the camera. The depth is essentially the length of this vector. So this is a vector 4 representing the position in I-space, and the depth is just the length of the XYZ component of that. And then we can jump back over to the pixel shader. Instead of assigning the world normal to output.extra, we can say output.extra is going to equal something like a float 4 of input.depth Did I spell that right? I think I did. And 1 on the alpha channel. Anyway, this isn't actually going to look like much. This is just going to be pure white because colors, as you probably know, range from 0 to 1. And depth value here is going to be much greater than that. It's going to be from 0 to whatever the distance from the camera is, probably about 100 in the case of what you see on the screen right now. And that is just going to appear on the screen as white. That's not especially useful. If we want to actually see a little bit of granularity in pixels depth from the camera, we can do things such as divided by 100, and this will work out so that fragments with a length of 0 from the camera are 100% black, 0, 0, 0, the color is black, and fragments with a distance of the camera of 100 are solid white, 1, 1, 1, solid white. Let me run the game again. There are other ways you can do this. There are other ways you can write something like depth to a surface. You can use all 4 color channels instead of just putting the same thing in each color channel and having basically a grayscale image. You can see now when I get closer, Link is darkening. If I were to rotate him on the spot, you would see that his hands darken when they get closer to the camera and lighten when they go farther away. That's depth. There are uses for this. Again, it would be nice if we had access to the depth buffer, but we can't always have nice things. Seriously though, I know GameMaker just had a major update relatively recently when it came to 2.3, but it would be really nice if we could have some shader related updates one of these days. Anyway, personally, I think writing the normal information. Personally, I think having the normal information being written to the surface looks a little bit prettier, and it's a little bit more to look at. It's nice and colorful. Anyway, I'm going to end this off here. As you can probably imagine, I will be doing things with this in probably the not-so-distant future. If I rotate him, oops, didn't mean to do that. If I rotate him, the normals are going to rotate too, don't they? That's, like, I like these colors, and I don't 100% know why. Anyway, play around with this. Expect to see more videos on things such as this in the future. There was one more thing I want to do with regards to toon shaders that will... Anyway, play around with this, see what happens. As I said earlier, this becomes especially useful when you write information that isn't just straight up color information to another surface. If you are familiar with the concept of deferred rendering, we will be visiting that at some point. Anyway, I have a Patreon, so if you want to contribute towards these videos being made, there will be a link to that in the video description. You can see your name in the credits, get these videos a day early, all that kind of fun stuff. If you want the code, there will also be a link to a GitHub repository in the video description. Otherwise, I try to post about 2 of these videos a week. This coming week might be a bit messy because I will be spending a lot of time not at the computer, and I may or may not have time to actually make anything next week, but we'll see how that goes. Otherwise, I hope you found that useful, and I will see you all later. Special thanks to David Key, Edward Holt, Emily Koyo, Jason, and Zenith for supporting these videos. If you want to get access to these things a day early, or to see your name in the credits, head on over to the Patreon page in the video description to join the fun.